Today, we'll learn how to download and execute hidden Python commands in this episode of Cyber Weapons Lab. A stager is a small piece of software that's typically used by malware to hide what's happening in the early stages of infection and later download a larger payload. Now today, we're going to explore how this works by creating a single line that downloads and runs potentially infinite lines of Python. And an attacker could use this to hide a really damaging suspicious payload in a way that a person who's just skimming through a new security tool might miss. Now the way we're going to unpack this is by base encoding our different commands in base64, and then uploading it to a JSON object so that we can pull it down, decode them, and run them one by one, while all keeping this within a single line of Python. Now to follow along, you'll need Python 3 installed on your computer. And if you're just getting started, you can check out our Raspberry Pi Hacker Kit linked in the description. Once you have Python 3 installed, then we can begin. Today, we're going to take a look at an interesting little piece of code that tries to hide what it's doing. And this is a pretty good model for understanding the way that a basic stager might work. Here we have a pretty basic line of code, and all it looks like it's doing is requesting some data and executing what looks like a base64 encoded string. And if you know anything about programming, this is already pretty alarming because you have no idea what's in this string and you have no idea what exactly it's going to do. But if we go ahead and just do a print, let's say we're analyzing this or something, we would probably only see one line of code and be like, okay, well, this is only running one line of code. Maybe it's not so bad. But again, this can be obfuscated even further. We could go ahead and make it so that the only thing you really see is just this exec base64 and then something in here, .decode, and you could have a really long string of commands that are basically the equivalent of all of this and really hide what's going on behind a single exec function. Okay, so what's the point of all this? If I run this, then what's the worst that can really happen? Well, in general, what you can do is take a payload, like this very simple payload right here, and if we were to run this, then you can see it's just a couple print statements, and it's verifying that it does in fact work. Now, if we want to hide this, we can go back to our previous code and look at the link and be like, all right, well, what's this? If we're going to be executing it, we might as well look at it. It's a JSON file. So if we go into a browser, this is really what it looks like. And if we go to the JSON input, we can see that this is what the actual code looks like. So this is all pretty confusing and it doesn't really mean much. So to the average person, if they see this, it's not a bunch of obvious commands. They would have to decode each one to really see what was happening. So if there were a bunch of innocuous commands in here and then a couple malicious ones, or if you were able to call these in different orders, so you could basically build a malicious structure with the commands that were stored in here, then the game starts to change because you don't know what order these are being called in, and you can start to do all sorts of other things to obfuscate the way the code is working. Now, these are all levels of deception that a stager might use in order to hide what its true intentions are, because you don't want to just drop your best malware in right away and then have all your exploits out there so that if someone catches it, they know exactly how to defend against it. Now here, let's see how we got to this point. How do we get these Python commands to actually be these strings, and how do we get it to run like this when we execute it? So if we go to our stager, and actually let's do this in a terminal window. If we go and take our code from the stager and just run it in Python, and this is just one line, then we can see what happens is this. We get a whole bunch of print statements, and that's not really what we were expecting because it was pretty short. So there's a lot of text here that's coming out of commands, and we actually don't know what's going on besides these print statements. So aside from the print statements, we could actually have a situation where other things are executing on the computer, and all we see is something deceptive that's trying to trick us into thinking that everything's okay. Now, all right, let's go ahead and quit from our Python, and what we're going to do is first take a look at this Python script, the one that we just wrote in our PyCharm, and we can see that these are the print statements in order to get it to run. So if we do Python 3 testpy.py, we should get the print statement here. Now, if we want to encode this so that we can upload it in this JSON object, what we can do is actually run base64 testpy.py, and this will encode the contents of this text file. And if I were to exec this after decoding it, it will go ahead and not only preserve the code that's in here, but the line break. So I can run multi-line code within one base64 object. And that's one advantage because you can have one kind of long object that looks like it's a single thing, when in fact it might be a bunch of different lines of code all kind of crammed into one. Now this is pretty awesome if we want to make it hard to analyze. And in general, our process here is going to be writing different payloads, converting them into a base64 string, and then dropping them into a data structure like we see here. And with each one of these messages, we have another different command that's being called. So, all right, let's go back and see in our PyCharm what is going to happen if we try to analyze this code a little bit. Let's say that instead of executing this sketchy thing, we're going to just print it. If we type print and run it, oops, let's run the correct one, stager. Then we can see for I in range 2 and then the length of data plus 1, execute base64, and then we have m and then a dot format and then I. So what this code is doing is starting a loop. It starts at 2 and it runs all the way to the length of the data. So as long as we have, and or as many different messages that we put in our JSON object. So this is designed to be flexible so that it actually makes sure that it includes every single message that is in the JSON object. So we can make as many as we want, and this code will find them and execute them one by one. Now this dot format is making it so that each time we go through the loop, we use the current variable I, which starts at, in this case, at 2 and then runs all the way to the end of the length of data, plus 1. Now I did this because I didn't actually start the m at 0. I should have started at m0 and then m1, m2, m3, and I wouldn't have had to do this. But for a rough draft, this is a pretty good way of explaining how you can iterate through a bunch of messages using a m dot format or some other dot format in order to use the I of the loop to jump through each of your messages. And to make that really clear, we have m1, m2, and m3. And these are all keys in our JSON object. So the way that JSON works is we have a key like this, and then we have a colon, and then we have a value. And in order to access them, in Python anyway, we need to make sure that we're specifying first the key and then the value. So here we have what we're specifying, m1, which is going to be the key, and we're basically requesting the data inside of it as the value that we're substituting here. So what we are doing is saying, hey, I want to put whatever is in whatever part of the loop we're in, m1, m2, m3, decode it and drop it right here, and then execute it in this loop. So that is a way that we can unpack our Python code and run a loop that jumps through all of the messages we've uploaded. And I just used m1 as an example, but any numeric sequence will work just fine. With this, we can go ahead and replace our print with an exec. And now, instead of seeing the first line of code, it's gone through and executed all the messages that we had in our JSON object. Now, for a beginner, this would be a pretty crazy thing to miss, because a simple line like this, or even a further obfuscated line that just execs a decoded base64 string, wouldn't really be something they would want to jump in and try to decode, because they might not understand how serious it is. But for anyone with more experience coding, then something that just looks like exec base64 decode and a long string should give you a lot of alarm, because if that command is the rest of this, then you could be in a lot of trouble as it downloads and executes as many lines as it wants and does really whatever it wants on your system. If you learn anything from this, it should be that you shouldn't just go ahead and download and run any new security tool without going through it first, and paying specific attention to any lines of code that are executing things you don't understand. Now, the exec function in Python is incredibly powerful and very dangerous to run if you don't understand what it's doing. So anytime you see it in a line of code, make sure you understand what's happening, because it could run, in our case, potentially infinite lines of code without you knowing what they're doing. That's all we have for this episode of Cyber Weapons Lab. If you need to do any troubleshooting, you can check out the article linked in the description. And if you have any ideas for future episodes, hit me up on Twitter @CodyKinsey, because I'd love to hear from you. We'll see you next time.